Good morning. So I continue with this lesson, but might be in the middle it will be finished, and I will switch to the last topic, which is trigonometric equations. Okay, and everything will be finalized by Wednesday. Yes. Okay. So there are things. So we learned about. Let me just refresh your memory quickly. So if you give me a trigonometric angle theta, what do I mean by that? I mean that the angle might be even larger than 360 degrees, or it might be even negative depending on the size. So you give me a trigonometric angle, then I should be able to motivate you. What do I mean by sine of that angle? What does it mean when I talk about the cosine of that angle? What does it mean when I talk about the tangent of that angle? So let me just briefly review what we did so far. So this means that if I have this unit circle, I start from always here, this line, and start finding the end point for my angle theta. Yes, so it might happen that I have to rotate more than even one revolution, or I have to move in the opposite direction. Depending on the sign of theta, because the positive direction by convention is here, the negative direction is there. But anyway, I will end up at some point on this circle, no matter how large the angle is, no matter what the sign of the angle is. The magnitude of the angle actually specifies how much I should rotate about O, and the sign specifies the direction of the rotation. But at the end, I will end up with one single point, which is on the circle, yes? And by the way, the unit circle means this standard one, that we always have the center at the origin, and its radius is one length unit. Okay, then for example, I don't know, you might end up somewhere here. This point has two coordinates x and y. Yes, you pick up the x coordinate and call it cosine of that angle. Yes, so cosine theta is equal to the x coordinate, and the sine theta is the y coordinate, and the tangent theta is equal to y coordinate equal to x divided by the x coordinate, of course, if the x coordinate is not 0. If it is 0, it is not defined at all. So that was the main thing that you need to learn, and now we practice a little bit about larger angles and using somehow the symmetry arguments to understand what is going on. For example, one thing we learned is that sine of 180 degrees minus theta is equal to what? Do you remember? It's sine of theta. That was based on symmetry argument, because if this is, for example, your theta, 180 is from here to here, so 180 minus theta is exactly this angle. And then you see that this becomes mirror image of that one. So if this is x and y, here this would be minus x and y. So this means that the y coordinate of this bigger angle is exactly equal to the y coordinate of this smaller angle. But so this means that the sine of this angle and the sine of that angle are the same, but you see that the x coordinates are opposite. So we also concluded that cosine of 180 degrees minus theta is equal to negative cosine theta. And of course, if you divide this by that, I told you that tangent of theta is always, remember, so y is sine, x is cosine. So that's also an extremely important relation in trigonometry to remember, that if you divide sine by cosine, the answer becomes tangent, yes? So then if I divide this by that, the answer becomes what? Tangent of 180 degrees minus theta. But if I divide this by that, it becomes tangent of theta, but because one of them is positive, the other one is negative, I get negative sign. So, and I told you, remember this as a, I don't know, English sentence or whatever. What is the name of this angle with respect to that angle? This is supplementary, because 180 minus theta plus theta is 180. So this angle and 180 degrees minus theta are supplementary angles. Why? Because when I add them, the answer becomes 180. And this means that the sine of supplementary angles are exactly equal. The cosines are opposite. This means that the tangents are also opposite. Yes? So that these kinds of arguments we already are familiar with. But now let us try to find another relation which is extremely important. And that is the fundamental, I would say, formula of trigonometry. And that is, if you give me any angle, theta, if I calculate sine of that angle and square it, and if I calculate the cosine of the same angle and square it, and I add these two numbers, this becomes always and always equal to 1. That is an extremely important relation that I want to discuss a little bit about this today in the beginning of the lesson. And by the way, I told you the convention. People usually doesn't write this pair of brackets, so people simply write it as sine theta, and that is conventional to put power of 2 here. But be careful, this means the same thing. And then you say that cosine theta squared plus sine theta squared is always 1, regardless of the value of theta. If you remember, we proved such a formula when we're dealing with trigonometry in the right angle triangle, but the domain of applicability of that formula in that domain was limited to acute angles theta, yes? But now I want to extend that, and I would say that, okay, whatever you had before only for acute angles, it is also true for every angle, even negative angles, even angles larger than 360 degrees, whatever. And the answer is again clear. Why? Because you give me a point, you give me an angle, and I will go and find it somewhere. It becomes 1 point on the circle. But because the radius of the circle is 1 unit, it means that whatever that point is, its distance to the origin is 1. Yes, that's clear. If you give me theta, depending on how large theta is, what the sine of theta is, I will start rotating about this O, and finally I will end up with 1 single point. Yes, that point is a point on the circle, so its distance to the origin is 1. So if you don't mind, let me call it B in this case. So this means that OB is 1. So the only thing that I really don't know is that if really B is here, I don't know. B might be here, might be here, might be there. I don't know. It can be any point there. But it doesn't matter. Wherever this point is, its distance to the origin is still 1. But there is a formula that I told you last time. What is the formula for the distance from a point to the origin? That has a formula. This means that the square root of x squared plus y squared. This is the distance formula. The coordinates of the origin are 0 and 0, but the coordinates of B are x and y. So the difference between the x coordinates is x squared, and the difference between y coordinates is y squared, is the distance from B to O. And this is supposed to be equal to 1. Then I raise it to power 2. It becomes x squared plus y squared is equal to 1. But now if I ask you what x is, you immediately answer x is nothing except cosine. So this becomes cosine theta squared. And then you have sine theta squared is equal to 1. But then you realize that I can write it as sine squared theta plus cosine theta squared is equal to 1. Yes, so that is something from now I really want you to memorize that. So if I want to, by the way, I have seen many students take square roots and write this. Yes, this is completely wrong. Yeah. You can take square root. There is no problem. You can take square root of the left-hand side. You can take square root of the right-hand side. That is correct. That square root of 1 is 1, but this is not correct that the square root of this combination is the square root of the first one plus the square root of the second one. So make sure that you understand and never use this combination. Okay? This is an identity, a trigonometric identity. So whatever theta is, this is always and always valid. Okay. Okay, so let us try to solve some problems related to this identity. Before doing that, I want you to visualize this in your head. This is also good to know that if you have an angle theta, I would say the first quadrant, I can write the second quadrant, the third quadrant, and finally the fourth quadrant, yes? So you remember what are these. So this is the first one, the second one, the third one, and the fourth one. So I want to see what are the signs, positive or negative, what are the signs of these trigonometric numbers. So if you are in the first quadrant, what happens for sine? Is it positive or negative? Because sine is the y-coordinate. You are in the first quadrant, the y-coordinate is positive. So sine in the first quadrant is positive. I don't want you to memorize that, you can immediately visualize it. So what about cosine and tangent? Cosine is also positive because cosine is the x-coordinate. In the first quadrant, x-coordinate is positive. And what is tangent? Tangent is nothing except the division of y to the x. Because y and x are both positive, so when I divide them, it remains positive. Yes? And then what do you do for number 2? When you go to the second quadrant, x becomes negative, but it's still y is positive. So this means cosine is negative, but sine is positive. But then tangent is the division of these two numbers, one positive, the other negative, so the division turns out to be negative. And when I go to the third quadrant, both x and y are negative. This becomes negative, negative, then consequently the tangent, which is the division, turns out to be positive. And the last quadrant, cosine is positive, tangent is negative, sine is negative, so the division is also negative. I don't want you to memorize that, but you should be able to visualize it. Okay? But let me give you an example. This type of example you might face in the exam, okay? So example, let sine theta be equal to, for example, minus 3 over 5. Determine the exact values. This word exact is actually important. The exact values of cosine theta and tangent of theta. By the way, I would say without calculators. Because if I don't say that, might be some students take a calculator and calculate theta. How? By putting theta is sine inverse bottom of this, and they get an angle. And then when they have the angle, you put it there, they get cosine and tangent. Of course, I am preventing that by writing the word exact, because if you do that, you get just decimal points, which is not the exact value, but the approximate value. Okay, so this is a typical example I want you to know. This idea of solving this problem is using this identity, which is always valid, and imagining this table somehow. So, because you see that when you give me sine, I can use this formula to find cosine, because they are related. Sine squared plus cosine squared is always 1. So I would write this. If I want to solve the problem, I will start writing the formula. And then the next step, instead of sine theta, I would write minus 3 over 5, and then to the power of 2. And then plus cosine squared of theta, is equal to 1. So you see, I have a relation, one equality, and there is only one single unknown, and that is theta. So in principle, I should be able to solve it and find theta. But before doing that, let us do some arithmetics. Yes, so I would raise it to power 2. It becomes 9 over 25. But plus cosine squared of theta is equal to 1. So I will keep it on the left, cosine squared, and then I move the other number to the right. Yes. But instead of 1, I can imagine 25 over 25. Yes. So this means that cosine squared of theta, cosine theta squared, this is the proper way of reading it. But 25 minus 9 is 16 divided by 25. Okay, I realize that the problem is not complete. I forgot about it. I told you that you have to imagine this, but I forgot to write the sentence. I will tell you why this is important. Because now if I ask you find cosine theta, if this is the problem like this, then what you should write for cosine theta? Can you tell me? Yes?
Should it be 4 over 5?
2 answers.
Plus or minus?
Plus or minus, yes. That is the point. This is why I missed that point. So plus or minus 4 over 5. If the problem is stated exactly as I have stated it here, wrong, not wrongly, but I didn't mean this, then both of them are acceptable. Or are they? Because when you say that sine of theta is negative, it means that, go here, sine theta is negative here or there, in the third or fourth quadrant. So you already know that theta is in the third or fourth quadrant. If you are in the third quadrant, cosine is negative. So the negative value is acceptable. If you are in the fourth quadrant, cosine is positive, so the positive one is also acceptable. So I didn't mean, by the way, to write this. But anyway, if you see this question, it means that both of them are acceptable, even though sine is only negative. Yes? Because by negativeness of sine, I realize that I should be somewhere here or there. If I am here, cosine is negative. If I am here, cosine is positive. So it means both of them are acceptable. Yes? I will give you another example. In that case, I have to consider both scenarios. So I would say that answer for one part is this. Cosine theta is plus or minus 4 over 5. That is a partial answer only to the first part. But then I want to calculate tangent of theta. I know the formula for tangent. It is sine divided by cosine. Sine has one single value according to the problem. It's minus 3 over 5. But cosine has 2 solutions. Both of them are acceptable. So I have to consider both of them, plus or minus 4 over 5. Then what happens? This 5 and 5 are cancelled. If this is negative, this is positive, I end up with negative 3 over 4. If this is negative, the denominator is also negative, I will end up with positive value. So this becomes positive. Anyway, plus or minus again. So I can add this partial answer to the problem as well, yes? So tangent of theta is also minus or plus 3 over 4. By the way, this is also standard. When you write positive on top and then suddenly you write negative on top, it means, by convention, that if you choose the upper side, you have to also choose the upper side here. So it means that if you have chosen the positive value for cosine, the negative value for tangent should be chosen. And when you choose the negative value for cosine, the positive value for theta should be chosen. If you don't like this, you can just write them separately. You can write cosine theta 4 over 5, tangent theta minus 3 over 4, or cosine theta is negative 4 over 5, tangent theta is positive 3 over 4. That's also possible. But anyway, that was not exactly what I meant, because most of the time they also give you an explicit information about the quadrant. So let me give you another example. So that is not wrong, by the way, but if you see this question, you have to consider both of them. If you just pick the positive one, it is not complete. Okay? Now let me just change the question slightly and then try to... So let me change the question. So let me also equip it with some star. It's good to remember this typical problem. It's a prototype problem. It's good to remember. So let me change this time. We can write let cosine beta is. Let me also change a little bit the numbers. So don't think the numbers should always be friendly, okay? It doesn't matter at all. So let cosine beta be, let me write it as 1/3, okay? Let cosine beta be 1/3. By the way, can I say let cosine beta be 3? That's also good to know. Why? We already talked about this, but it is more clear here. Can I say let cosine beta be 3 rather than 1/3?
No.
Yes?
Isn't it because we are like in the unit area?
We are in the unit circle, yes? So cosine and tangent, sorry, cosine and sine are what? Are x and y coordinates of some point on the rim, yes? But because this is the unit circle, the maximum value for y is 1 unit. The minimum value for y is -1 unit. Okay? And the maximum value for x is +1. The minimum value is -1. So it is clear. I think it also deserves a remark. Remember this. So sine of any angle is at most equal to 1. And in the lowest, it is -1. The same is true for cosine. Because sine and cosine are nothing except that coordinates, yes? But there is no limitation in principle for tangent. Tangent can be any number from -infinity to +infinity. And that is also somehow clear. Why? Because tangent is the division of y over x. If you make a smaller and a smaller and a smaller, you are making the fraction bigger and bigger and bigger. So there is no limitation for the tangent. You see, if I make this theta very, very narrow, then, very narrow makes x it makes x very big. I want to make x very small. So I go a little bit up. If I am here, the x coordinate is this much. If I get closer to 90 degrees, the x coordinate becomes smaller. I can make x smaller and smaller and smaller. So this means that this fraction becomes bigger and bigger and bigger without any bound. So tangent can go really up to infinity. So for example, you can punch tangent of 90 is an error because that's not defined. But tangent of 89 is a big number. So you can make it even bigger by writing tangent of 89.9. You can make it even bigger, tangent of 89.99, yes? When you start getting closer and closer to 90, the denominator becomes smaller and smaller and smaller. So in consequence of that, the fraction becomes bigger and bigger. You can test these numbers with your calculator, okay? It's good to write these three as a remark somewhere. So this is why I cannot say let cosine beta be 3. If I say that, then you will immediately complain that cosine cannot be larger than 1. Yes? But here that's okay. So let cosine beta be this, and let beta be in the 4th quadrant. Yes? Determine the exact values of sine beta and tangent beta. I would say that this is mostly the same problem, but I have added this kind of sentence or phrase there, yes? I have given you where beta is, so there is no matter of confusion. Because you see here, when I say cosine beta is positive 1 over 3, so I go for cosine, there are two quadrants that cosine can be positive in, either here or there. So, and then I have chosen you to say that, okay, let beta be in the fourth quadrant. For example, I cannot tell you cosine beta is 1/3 and let beta be in the second quadrant. No, it's not possible, because in the second quadrant cosine is negative. Yes? But this is consistent at least. I have given you a number which is allowed because it is in the range, and I have been careful in telling you the quadrant. So beta is in the fourth quadrant. When I say cosine is positive, I have to decide to choose either the first quadrant or the last quadrant. Okay, I have chosen the last. Determine the exact values of sine beta and tangent beta. Okay, I think you know the answer. Yes? So what should I do? I start from this equation. Sine beta is unknown here, so I copy and paste again. But cosine beta is given to be 1/3, and I square it. Is equal to 1. And I do some arithmetic here. 1 over 3 to the power of 2 is 1 over 9. Is equal to 1. I move 1 over 9 to the other side. It becomes 1 minus 1 over 9. But instead of 1, I put 9 over 9 minus 1 over 9 because 8 over 9, yes? But then I want to find beta, sine beta. So sine beta is plus or minus the square root of 8 over 9. But of course the denominator is simple. It's a square root of 9, which is 3. A square root of 8, you can write square root of 8, but I prefer to write 2 square root of 2, yes? Square root of 8 can be written as a square root of 4 multiplied by 2, which can be written as a square root of 4 times 2, and then it becomes 2 square root of 2. But these are not very important things, you can just write it like this. But then, in this problem, this is not the case that both of them are acceptable. Yes, because I have emphasized in the problem itself that beta is in the fourth quadrant. So if you go to the fourth quadrant, sine is negative. So you cannot say both of them are acceptable. So you need to write, since beta is in the fourth quadrant, sine beta is positive, is negative. Sine beta is negative. So, sine beta is the negative answer that I give, not both of them. Only the negative one. So this is partial answer for sine beta. But then the rest of it is clear, because I am supposed to find tangent beta. Tangent beta has a formula, has a relation with sine and cosine immediately. So instead of sine beta, I just write this number that I have here, and then I divide it by 1 over 3. But this 3 and that 3 are gone. I get minus 2 square root of 2. So tangent beta is minus 2 square root of 2. Did I expect to get a negative value? Yes. Because if you see in the fourth quadrant, tangent is also negative. So that is something that I want you to know. Okay, sometimes they might give you this question without specifying the quadrants, then you have to admit both of them. But sometimes they also specify the quadrant. Then in that case, if you write both of them, that is not correct. Okay, before leaving this section, I see that a good problem with 2 stars is there, so let me just solve that for you and then we can move on to the next topic. So the question is that, show that, so this is question in the hard copy, I don't know what the number is in the digital version. Show that, I will write the question, show that cosine v, or the Greek letter nu, divided by 1 minus sine nu, plus, again, cosine nu divided by 1 plus sine nu is equal to 2 over cosine nu. Okay, so we will study this in greater depth actually in Math 4. So that is, I would say it's a Math 4 problem, by the way, but let us see, because might be that's the reason that they put double the star here. I don't think you get some question like this even at the national exam level, because this is mainly the topic of Math 4. But this is not something that you really cannot do. Okay? So this means that show this equality is true not for every nu, because sometimes sine of nu, for example, if nu is 90 degrees, then sine of 90 degrees is 1, and then 1 minus 1 makes trouble. But forget about those things. I mean, if nu is an angle so that this is not 0, this is not 0, and this is not 0. In that case, we want to show that this is always true. So there are not that many angles. I mean, there are infinitely many angles, of course, that sine of nu is 1, infinitely many angles that sine of nu is minus 1, and infinitely many angles that cosine of nu is 0. But there are also much more infinitely many angles where they are not. So we want to prove this for those cases that we don't have any problems. Okay? So if I want to solve this, let me just solve it for you and see that. This is a good, because you need to combine algebra and trigonometry. So I want to show that this is equal to that. So I will start with the left-hand side and try to simplify the expression as much as I can to get to the other side. So what can I do here? Do you have any ideas? By looking on at the left-hand side, you see I have 2 fractions involved, but on the right-hand side I have 1 single fraction. So somehow it motivates me what to do. What is the motivation? Just a naive guess, yes?
Just add them together.
Add them together. So I have 2 fractions, I want to add them to make them 1 single fraction. But of course, the reason that it got 2 stars on it, because might be this is algebraically a little bit involved. So can you tell me, what should I do? If I have 2 fractions, and unfortunately the fractions have different denominators, so I have to make the denominators the same. It's more involved. Of course, I did the denominators the same here, you see, but it was so simple, you even didn't ask, yes? Instead of 1, I wrote 25, 25, so the denominators become the same, and then I did the calculation. So now, I want to make the denominator of this one by that one the same. So I have to rescale this, and rescale this, so that after rescaling, I see the denominators are the same. So can you tell me, how should I rescale it? Yes?
You can multiply the one with the 1
Plus,
Yes,
exactly. So I multiply the first fraction by that, and the denominator is also should be multiplied. But let us step back and see what we have done. I am claiming that this fraction, this simple fraction, is also equal to this fraction, yes? Because what I did, I just multiplied its numerator by that expression, but I was careful to divide by that without changing anything. Everyone agrees that this is the same. Okay, so I will do the same thing for the next fraction. So what I'm supposed to do, it becomes cosine nu, and then I multiply this by what this time?
1 minus.
1 minus, yes. 1 minus sine nu divided by 1 plus sine nu multiplied by 1 minus sine nu. Yes? This is very good, at least, because now I see again 2 fractions, but I don't have that problem anymore because now the denominators are exactly the same. So if the denominators are the same, what can I do to add the fractions? I just copy and paste the denominator. Yes, let us take this denominator. They are exactly the same. But then what I have to do, I have to add the numerators. Yes? Okay. So I wouldn't say it is very hard, but we could do it. But the next comes with some simple calculations. Okay, so help me to do the numerator. So what is your suggestion for the numerator? Yes?
Could factor out cosine.
One way is to factorize, but let us, because factorization in usual is harder. It's completely working here, I agree with you, but if you don't mind, let us multiply here. Because the general theme is actually to multiply, but do not touch the denominator as much as what you can, okay? So even though what you said, Rocco, is completely correct, if you factorize, factor cosine out is completely working and you get the full mark. But generally speaking, we simplify the numerator. So it means that in principle, we expand, okay? So we do that. So I will expand that one. So cosine nu plus cosine nu sine nu. And then I will get cosine nu minus this time cosine nu sine nu. But the denominator also is reminiscent of actually some identity. What that identity is? What that identity is? It's a very famous pattern.
Squaring or
No,
the other?
it's the conjugate rule. Yes. I have two numbers. One of them is 1, the other one is sine omega. Once subtracted, once added, and then I'm multiplying it. So that's the conjugate rule. So it becomes what? It becomes the first one squared minus the second one squared. But now look, what can be done in the numerator? It's good, you see, this one, I hope that you agree there is no difference between that one and that one, except that one of them is negative, the other one is positive. So this one and that one are totally gone. But what can I write instead of cosine nu plus another cosine nu? 2 cosine nu, yeah? So that is good, at least 2 appears. But let me do something here. This 1 to the power of 2 is what? Again 1. Let me just get rid of this 2 because there is no difference between 1 squared. But now, instead of 1, I can use this rule that 1 can also be written as sine squared nu plus cosine squared nu. Yes? If you ask me what this combination is, that combination is exactly equal to 1. This is the first time that I am using trigonometry. Because here, this is more or less algebra. Of course, I am working with sine and cosine, but it doesn't matter. I am just working them as numbers. But this is the first time that I take 1 away and write something instead of that using my trigonometric knowledge. And then minus sine squared is the rest. Yes? And now what happens? Sine squared nu minus sine squared nu are cancelled. So what is left in the numerator is 2 cosine nu divided by cosine squared nu. But cosine squared means cosine multiplied by another cosine, yes? Cosine squared means cosine times cosine. But this one of these cosines and that cosine are cancelled. Why? Because they are factors. Factors can be simplified. And then what is left in the numerator is just simply 2, and the denominator is just simply cosine nu. And if you see, that's exactly the expression on the right, so it becomes the right-hand side. So that was actually a hard problem, yes. Any questions? Yes?
So the whole table with the quadrants, will we get that on the exam?
No, you should imagine that. I told you, you don't need to memorize. It was very simple because by just imagining, you know that in the first quadrant, x is positive, y is positive. X is cosine, y is sine, so both of them are positive. If x and y are positive, the division is also positive.
So we need to understand and remember how it
Yeah,
works.
yeah, because this is not given in the formula.
Okay.
Why did you factor out that sine squared?
I didn't factor out. This is positive, sine squared. This is sine squared with the negative side. So when I am adding three numbers, one positive, one negative, they cancel out.
Which rule was that? When you transferred 1 to...
There is no
sine
rule.
squared?
This is this famous trigonometric
Okay.
identity. Of course, we prefer to make things simpler, but this one was a little bit harder. By seeing a little bit ahead of me, I took one, which is very simple, and made it a little bit more complicated,
Yeah.
but with the goal to get rid of that sine squared, yes. Okay, now I switch actually to the last topic of this Math 3C lesson. Again, I don't like it that much because we have to repeat everything even more completely in Math 4, okay? It might be you get some questions in the national exam. Let us just do it. Okay, and we can review it, please. It's, by the way, an important topic, and that is called, let me change the title now. So, trigonometric equations. So might be we can finalize the lesson today, but on Wednesday I will solve more problems for you. And I have already, I think if I am not wrong, I have already uploaded the exam, national exam questions on Google Classroom. I will never ever be able to solve all of them for you. So I recommend you, if you really are serious about that, start practicing yourself mainly. And then, I don't know, I can choose then one of them for you and try to solve them from the beginning to the end. So trigonometric equations. Of course, if you remember, I started talking about trigonometric equations for you, and you yourself were able to give me some ideas. But let me just review everything, okay? So what do I mean by trigonometric equation? Of course, whenever equations are coming in the mathematics, it means there is something unknown, I want to find it. And then when you have this adjective trigonometric, it means that the unknown is an angle which is hidden in trigonometric functions like sine, cosine, tangent. For example, I can ask you, give me theta so that sine of theta is 1 over 2. Okay? The whole point, when I say solve, the word solve in mathematics implicitly means find all possible angles, not just one. Even if you find one, that is not wrong. For example, if you use your calculator, immediately it provides you with an angle. I have intentionally chosen a number that I have it in my memory, so if you punch it in your calculator, so you will get theta is sine inverse of 1 over 2, and then it becomes 30 degrees. Okay? But I cannot claim that I solved the equation. I found an answer, that answer is totally correct, but I cannot claim I solved my problem, I solved my equation. Because the word solve means find all of them. Yes? This is one of them. Or you have to convince me there are no others. If you can convince me, yes, that's a solution as well, but there are infinitely many more. That's what I want you to understand. But let me try to understand this geometrically. So I told you the calculator will only give you one angle, 30 degrees. This is helpful, but not the end of the story. Let us to understand this. I give you a ruler, and I give you a protractor or whatever you need. Assume that you have instruments, and they are God-given instruments without any errors. Okay? And I want you to use these tools to find theta. What do? You draw a unit circle. Okay, and then it is possible for you because you use your God-given ruler and then measure 1 unit of length, and then you get your God-given compass and you draw the circle. Okay? Okay, but now can you tell me, I have a compass, I have a ruler, I have a protractor, and using these 3 tools I want to find all possible values for theta. So what is your suggestion? Assume that you have these three rules in front of you. We already used some of them. I took my ruler and I draw straight lines, and I used the ruler to measure 1 unit of length, and then I draw the circle. And then what I do, I want to find that theta, all of them. So how should I do that? You know something about sine of an angle. Sine is related to which coordinate? Y coordinate. So it means that the question can be reduced to another question. Can I find the points on the circle which have 1/2 as the y coordinates? Yes?
Should we maybe draw a mini circle inside that circle?
No, not mini circle.
Half circle?
No. No, there is no circle involved. There is another object involved.
Right.
Because you want to have a height equals to 1/2. So what is the natural one? Yes?
Triangle?
No, come on guys.
A line?
A line. Yes, exactly, a line. So I take my ruler and measure 0.5 here. Assume that this is 0.5. And then I take my ruler and draw a horizontal line here. Why horizontal line? Because if you tell me this is 0.5, then every point on this line, I am sure about something. I am sure that the height is 1/2. Yes? But these points are not important for me. I am caring about the points on the circle. There are 2 points important. One of them is this one, the other one is that. Yes? Okay? So if you tell me how many points are on this circle whose y coordinates are 1/2, there are 2, not more. Agree? One of them is here, one of them is there. There are no other points. If I start moving a little bit higher, of course the height becomes more than 1/2. If I go in the other direction, the height becomes lower than 1/2. So there are only 2 points, one on the left, one on the right, whose y coordinates are 1/2. But the question is that, how can I measure the angle? Because I want to find the angle, okay? One thing that I can do is to take my ruler, put it here and there, and draw a straight line, and then take my protractor to measure this angle. Yes? Well, that is one of those angles, which, by the way, which angle is this? Is exactly 30 degrees if you calculate. But forget about calculation. You take your protractor and measure this angle, you get 1 theta 1. So one answer to this problem is theta equals to theta 1. And there is another one, yes? Because there is another intersection point. So what I am supposed to do, I am supposed to take my ruler again, put it here and there, and then draw this line, and measure which angle. Because I told you that every angle should be measured from this line. So I have to measure another angle here, which I call it theta 2. Yes? So then it means that another answer to this, which is not provided by the calculator, is theta equals to theta 2. Yes? There are 2 angles. So that is why calculator only gives you one of them. The other one is theta 2. What is the relation between theta 2 and theta 1? Yes?
They are supplementary.
They are supplementary. So in other words, theta 2, theta 1 is enough if I have the knowledge. Because I use the calculator, I get theta 1, but I myself know there is another one which calculator will not give it to me. The other one is the complement of this one. So this is 30 degrees, but then I realize the other one is the supplement, is this one, which is 150 degrees. And the calculator will not give this one to you. And that is the reason. Do you remember when I was teaching you the sine rule, I told you momentarily memorize that there are 2 solutions, but that is really the reason there are 2 solutions. But the word solve, you have to be careful. Are there other angles whose sine is equal to 1/2? And the answer to this question is clearly yes. Why? Because if I start from here and go 1 full round, I come back exactly at the same point. Even though the angle has changed, but the height is the same and the sine remains the same. Yes? So this means that, let me just ask you one question. So if I have theta 30 degrees, but this theta degrees is here, but this point corresponds to infinitely many other points. One of them is 300 plus, 30 degrees plus 360. This is one of them. Another one, 30 degrees plus 2 times 360 degrees. Agree? And I think you can see what happens in this list. Can I go in the negative direction? Yes. I can write 30 degrees, but instead of going one full round in this direction, I go one full round in the opposite direction. So this means that this would be minus 360 degrees. I will end up with a new angle. And I can go here one more, yes, 30 degrees minus 2 times 360 degrees. You see, if I ask you, are these angles the same, you would say no. Of course the angles are not the same. This is 390. I don't know, this is 750. But the angles are not the same. This is minus 330. They are not the same, but all of them end up at here. And what matters for sine is the end point. So all of them are acceptable. Instead of writing so much expressions, people write it in a short form by writing 30 degrees plus any integer number n multiplied by 360 degrees. It doesn't mean that this is one angle, no, because how many choices I have for n? I have infinitely many choices. N is an integer. Instead of writing this in English, n belongs to the set of integers, means n is an integer. So I would say that theta is equal to this angle, these angles. These angles, there are infinitely many angles, but all of them corresponds to one single point on the unit circle, and that's that one. Yes?
Shouldn't you also mention that theta is equal to 150 plus n?
Yes, it's not finished yet. This is one part of the problem. But this is one category, one group of solutions. But how many solutions are in this group? Infinitely many, one for each choice of n from the set of integers. But this is not the whole story, you can immediately realize, because I am just caring about this point. What about the other point? I have to take care of that one as well with the same strategy. Yes? So it becomes what? Or theta is what? Instead of 30, what is 150? Repeat the same argument. But in principle, because you have already used letter n for this purpose, to be really strict, you have to change the name of that. Okay, I would write m times 360 degrees. And then I would say that m is also an integer. But I have seen in some books they don't differentiate, even though technically it is not correct. Okay? If you write n here, so it means that you are forcing these to be the same. But of course, because on the other hand we have or, there is no confliction because you say that either this one is true or that one. So if this is 1, this is n, this is 1. They are not happening at the same time. But anyway, so what I am asking you to understand, and then I will go faster a little bit for the case of cosine, but because the idea is to repeat this process once for tangent, once for cosine, and once for tangent, and then we are done. Okay, so what we are supposed to do. Okay. So, if I give you this equation, and I ask you to solve that, what I expect you to do is to take your calculator. So let me write the complete form, okay? If you don't have the calculator available, and if you don't have a table, what we're supposed to do. You imagine that you have your calculator. So 1 theta, you need to write 2 thetas with over, yes? What you put here, of course in this case, it was 30 because I had this number in my memory, okay? Okay, so let me, by the way, let me change this one to the general case. Instead of giving you 1/2, let me just write any number, k. But of course, when I say any number, I have to be a little bit careful. Why? Because, for example, if I ask you solve this equation, what is your answer to this immediately?
It doesn't exist.
There are no answers because sine cannot exceed over the 1. Yeah? So if I give you this and I'm careless, lucky you, you said that there are no answers. But I have to be careful that the number that I give you is somewhere between what and what?
Was it -1 and 1?
Minus 1. Okay? In that case, imagine this is the same thing happening to you. I want to discover, because these formulas are also not in the formula sheet. You have to imagine this to be able to generate the formula and have a strong memory to memorize that. Both of them, by the way, are good. Okay, I don't underestimate memorizing. But of course, understanding is more important. Okay, can you tell me what is the recipe? I give you this and I ask you to find theta. I mean, I want you to solve this equation. So what I'm supposed to do? I take my calculator. Imagine that you have your calculator. What do you punch in your calculator?
Sine.
Inverse of this number.
Yes.
Yes, so I would write sine inverse of that number. I didn't write sine inverse because the sine inverse one was easy to understand in this case, and I wrote 30 instead. But in general, I have to write sine inverse of that number. But is it finished? No, because sine inverse of a k gives me 1 point, and I can go 1 full round above that point, yes? So this becomes plus n times 360 degrees. And then I would mention that n belongs to the set of integers. But this is not the whole scenario. There is another alternative. What is that one? Do you remember how we got 150? Yes.
180 minus n.
Not minus n.
Minus k.
No,
Minus sine inverse.
minus sine inverse. Because this number is playing the role of 30 here. Yes. So whatever this number is, I have to write 180 degrees minus sine inverse of k. And then plus probably m times 360 degrees. M belongs to z. Do you understand what's going on? Don't get confused. So if you see, in this case, instead of having sine inverse all the time with me, it was easy to calculate. This is a famous number. I had it in my memory. Sine inverse of 1/2 is just 30. But if the angle is not the famous one, I have to live with it, or I have to have my calculator handy to be able to calculate it. And extremely important, make sure that your calculator is in the degree mode if you want to solve it. So this is something you really need, but it is not in the formula sheet. Okay? So this you need to imagine. By the way, it is not hard at all, because you don't need to be distracted by this part. This part is easy to understand. You just go 1 full round, yes, or a multiple of a full round. The point is that if one angle is provided by the calculator, what is the other angle? This is the picture that you need to imagine, how these two angles are related. One of them is the supplement of the other. Yes? Is that clear? Let us immediately go to the cosine case. I again go back to the same scenario. For being able to calculate these things properly, let me just stick to this number that I have in my memory, okay? I go back to this God-given tools, yes, and I this time ask you to measure, not calculate, okay? Try to do this wisely, and I ask you, how do you find all angles theta satisfying this relation? I'm looking for all those angles theta whose cosine are equal to, whose cosine are equal to 1/2. Of course, again, if you have your calculator handy, you can immediately answer one of them. How? By punching this into the calculator. Punching what?
Cosine.
Yes, I would write theta cosine inverse of 1/2. And I have this particular one in my memory. It becomes 60 degrees. Okay, but that is not the end of the story. The same story. Let us repeat this so that you understand everything. Okay, now let us try to use our tools to measure the angles. Okay, what I'm supposed to do this time? I go and draw the unit circle. This is possible using my tools. And then now I want to hear from you because this is the important part. So what I am supposed to do with my tools? Anyone else? Yes, Abdul Rahman?
Because we want cosine.
Yes.
Forget.
Okay. Oh, that was correct. Not bad. Yes, Aaron?
It's the x coordinate.
X coordinate should be 1/2. So what should I do?
You draw a line.
Vertical
Yes,
line.
that
That's
x
clear.
equals 1/2.
Yeah, so I mean that you need to understand that. When you understand it, it's easy. So I use my ruler, measure 1/2 for the x coordinate, and this time I draw a vertical line rather than a horizontal line. What happens? I get two intersection points. Yes? Are there more than these 2 points whose coordinates are x? 1/2? No. These are the only ones. There are infinitely many, but only 2 of them lie on the circle. So they are important for me. And then I take my ruler and draw this line. And take my protractor to measure this angle. This angle, let me call it theta 1. So one of these angles, theta, I measure this angle using my protractor, and I say that theta is theta 1. This is one possibility. But is this the whole story? No, because there is another group of points. So there's another point actually here. Okay, so it means that what should I do to measure the angle for this one? I have to connect this to this one. And then remember, I start always from here, and I have to measure this angle. It is theta. So this is the way that you have to imagine. Otherwise, it might be hard for you to memorize which one is which. Okay? Now, but I hope that you agree with me, there is a relation between theta 1 and theta 2. Of course, you can write theta is equal to theta 2, but is there any way that I can write something instead of theta 2?
360 minus.
360 degree minus 360 degrees minus
Alpha.
not alpha, theta 1. Yes, so you see, in the case of sine, one of them is the one with the given by the calculator, the other one is 180 minus that angle. You need to visualize to understand. But in the case of cosine, for this geometry, that it was natural because you just told me what to do, and we have to live with it. So the second angle is 360 minus that angle. Yes? And do you remember, I told you in the cosine rule, in the triangle, don't worry about the second one. I told you memorize it for the time being. But you will see that you don't need to be worried for another angle. Why? Because in triangle, this angle cannot happen. One angle is an acute angle, at most 90. 360 minus an acute angle is a number larger than 270 degrees. So in the case of cosine and triangle, you really don't need to be worried about any other answer rather than the one given to you by the calculator. Yes? But for the case of sine and the triangle, you have still to be worried about another one, because this can happen in a triangle. This one cannot happen in a triangle. Yes? So if I want to write a recipe, by the way, some books write like this. I don't like it. I write it as just minus theta. Do you also think this is acceptable? Because if you write like this, it means that you are taking this angle and that angle into account. But instead of, if I want to reach to this point, of course I can go in the positive direction and reach to that point, but I can also go in the negative direction. But if I go to the negative direction, the size is exactly theta 1, but it is in the opposite direction. So this is why some books write the second angle like this, but some books write the second angle just like this. But both of them are acceptable. And I would prefer the negative one only. Okay, that's up to you. So, but let us try to write the general form. The general form, just to help me to write it down. So cosine theta is what? Cosine theta is k. Again, k is a number between -1 and 1. The question is what theta is. Okay, can you help me to write something similar to that? Because that is up to you every time. Either you should have memorized that by working hard, or every time you have to imagine it. Okay? So let us imagine. Can you help me to write the formula similar to that, to the cosine case? Yes, Robert?
Theta is what was it called?
Cosine inverse.
Yeah, cosine inverse of k.
K.
But can you put plus minus before it?
Yes.
And then plus 300, plus n times 360.
Yes. And the way that Robert mentioned is actually the reason that I prefer this minus sign. Because I can compactly write them in one single formula by writing plus and minus. In principle, if you want, you can write it like this. Cosine inverse of k plus n times 360. Or the other one is what? 360 degrees. If you write that, that is also completely acceptable. If you use this, then I am using this version. Yes? One of them is provided by the calculator. The other one is 360 minus the one provided by the calculator. Okay? But if you write it in that way, this is inevitable. You have to write two separate formulas. But if you choose to write with minus theta 1, then you can write plus or minus. Plus for the plus 1, minus for the minus 1. It's written more compactly. But if it's confusing, you can stick to this convention for the time being in Math 3C, because it will repeat everything. But sooner or later, it will be good to learn this one as well, okay? Okay, there is no time if I want to go to the last one, which is tangent. I prefer to solve one example for you to see how we can use these formulas in practice. So there is only one single part left, and that is how we can solve equations related to tangent. There is something that we have to be careful regarding the tangents, okay? And before that, before finishing the lesson today, I would say that, okay, let us solve one or two examples depending on the time. Okay, one problem is also enough. So, I would say that let us solve this equation. Solve. So this equation, let me write sine, for example. 2x minus 135 degrees is equal to, let me write a number that I have it in my memory. I don't need the calculator in that case. So here let me write 1 over, or a square root of 2 over 2. This is one of those numbers that I have it in my memory. So it is clear that I am looking for x. When I say solve, I mean I want you to find x. It's a trigonometric equation. Why? Because trigonometry is involved, equality is involved, and unknown is also involved. But the unknown is inside the sine functions. Okay, if I want to solve this, can you help me to solve this? The formula is on the board. So that is something that you have to visualize from those pictures that we had before to be able to solve. That's a harder question. So this is something that you need to understand. This whole package is actually playing the role of your theta in this case, because theta is unknown. Okay, and then if theta is playing the role of that package, I can go up there in the formulas, okay? So I would write that theta, which is 2x minus 135. So you see, in the exam, if this is given, I would recommend you to go to a scratch paper, immediately visualize and write that formula, because you have to visualize and find the formula yourself. And then, because you might even immediately forget, write it on the paper, so then you have your formulas in front of you, and then you start solving the question. So this becomes what? Sine inverse of this number plus n times 360 degrees. And by the way, at the very end, you really have to mention that n is an integer, otherwise it is not complete. But then what you need to do, you refer to the table, because there would be a table of values, or if it is in the calculator part, you can use your calculator to answer it. But this is, I have intentionally chosen a number in my memory, it is 45 degrees. Okay, before going, there is an or of course, but don't be in a hurry. Let us finalize this and then we jump to the or part. So this becomes 2x minus 135 degrees is equal to 45 degrees plus n times 360 degrees. But still the problem is not finished, because I was not looking for theta, I was looking for x. So this is now a very normal equation. So it means that I'm looking for x, so I have to make x alone. And this means that 2x is equal, let us do it in our head, yes? 135 negative, move to the other side, and add it to 45, which is 180, yes? And so you move this to the other side, it becomes 180 plus n times 360 degrees. And then you divide everything by 2. It becomes 90 degrees plus n times, when you divide by 2, you have to divide this by 2 and that by 2, not just one of them. So this becomes 180. Yes, so that is the answer. For example, if I ask you how many answers we got for x so far, you say infinitely many, 1 for each choice of n. If I ask you, can you give me some of them for me, you would say, for example, you choose 0, I get 90. You choose 1, I get 270. You choose minus 1, I get minus 90. And then you can put all the numbers from integers here and generate numbers. So those are all acceptable. That's it. But there is an or part, yes, that is one part of the problem finished. There is another part that I have to use this. But that is more or less the same thing. So I use this formula. This is why I'm saying that. It is better to go with the scratch paper, immediately visualize and write the formulas in front of you, and then start using it. So let me just start solving it here. So what I do, the other part is or is equal to, what was that? 180 degrees. I'm just rewriting that formula. Yeah. Sine inverse of k, which is square root of 2 over 2, but plus m times 360 degrees. Of course, I also have to write m belongs to c. But then that is simple. So let us just be patient. So 2x minus 135 degrees is equal to, what is the answer here? 180 is 180, but we already calculated that, that's 45 degrees. And then I have plus m times 360 degrees. Let us simplify this. So what happens? So 2x, I move this one to the other side as well. Let us do some calculations. 180 minus 45, 135, another 135 here is 270. And then I have m times 360 degrees. And because I want to make x alone, I divide everything by 2. So this becomes 135 degrees again, and that becomes 180. So you see, I get infinitely many angles, but in two separate groups. One group is this. It's also good to visualize all possible points on the circle. Okay? Even though this is not wanted in this problem, but it's also instructive if you do that. So what can I do? Let us try to change my colors for different groups. So how How many angles are there? Infinitely many. These infinitely many angles are falling into two groups. Let us try to understand them geometrically on the unit circle. So where are they, by the way? Let us try to pinpoint them here, yes? So, can you tell me what are the final points of these group? And this is not hard. For example, choose n equal to 0. What do I get?
90.
90. Where is 90? Up there. This is one group. One. Let us choose 1 here. What is the answer? 270. Where is 270?
The bottom point?
Bottom point. That's also another one, which is separate. So I have to pinpoint this as well. But let us put 2. Then what happens? The angle is 360 plus 90. It is bigger, but I will end up with the final, this up point, yes, the upper point.
Yeah.
So there is no. So it means that these two are infinitely many angles, but they themselves fall into two top type of points, the upper point, the lower point. Yes? What about these, by the way? If you put 0, I get 135 degrees. So 135 degrees is, for example, here. And then I choose another one. 1. Where is 1? I don't need, by the way, to calculate. If I put 1, it is that angle, but 180 degrees more. Where do I end up? I end up exactly here. If I am here, I go 180 degrees more. I end up here. But if I choose another one, I get 180 more, which I will end up with the same point. Yes? So it means that these two orange points corresponds to these formulas, and these two. So it means that in total, how many points are specified on the circle? 4 points. But 2 of them can be written as one single formula, and 2 of them can be written as one single formula. So I need 2 formulas, but remember there are 4 points. And how many angles? Infinitely many angles. Yes? Questions?
No, I was just thinking, don't you have to also write m as an integer?
I wrote it up there.
Oh, yeah.
But I have to write. You don't need to write every time, but at the end remember that you have to mention what m and n are, because m and n, of course, we know it's a very good chocolate, but yes, but here m and n is representing something else, okay? So people have right to ask what m is, what n is, because m and n are not in the beginning in the problem. So when you use them in mathematics, you have to address what they mean, okay? So there is only one single thing left from the course, actually the whole course, and that is the equation for tangents. So you see there is a very small difference between tangents and sine and cosine. We will finalize it, I think, at most in half an hour, and then I will continue solving some problems for it, okay? And I will update the Google Classroom to what we're supposed to do. Questions? Okay, thank you. The lesson is finished here now. Thanks.